Welcome to The Explainer. Today, we are going to tackle one of those classic computer science problems. You know, the kind of question that really separates the junior devs from the senior ones in an interview.
All right, just imagine it for a second. You're in that high-stakes coding interview. The pressure is on. We're about to walk through the exact problem that can make or break your chances. And trust me, by the end of this, you're going to know exactly how to ace it.
So yeah, think of this as your personal guide. We're not just gonna solve the producer-consumer problem, we are going to absolutely master it. We'll look at every trap, every pitfall, and of course, the best modern ways to handle it.
All right, let's get into it. The interviewer kicks things off by just laying out the basic scenario. See, before you even think about writing a single line of code, they need to know one thing. Do you really get the fundamentals?
So they're probably going to ask you to just define it. And at its heart, the producer-consumer problem is really all about coordination. You've got one process, the producer, creating data. You've got another, the consumer, using that data. But here's the catch. They both have to share this limited, fixed-size space. The real puzzle is how do you keep them from basically tripping all over each other?
And this is where a great analogy comes in, because it makes this kind of abstract software problem feel really tangible. The classic one is a factory conveyor belt, right? You've got a worker, the producer, placing items on the belt, and another worker, the consumer, taking them off. The belt itself, that's our shared buffer. And it's simple. If the belt gets full, the producer has to stop and wait. If it's empty, the consumer has to wait. And that's it. That is the whole problem, right there.
Okay, nice. You've just defined the problem perfectly. So now the interviewer kind of leans in and says, all right, show me the code. This is the moment. They want to see if you can build a really solid, robust solution from the ground up using the classic tools of the trade. And to do this, you're going to need two key tools in your toolbox: wait and notifyAll. Think of wait as basically telling a thread, hey, you can't go any further right now, so just go to sleep. Don't waste CPU cycles. And notifyAll is the exact opposite. It's like the shift manager yelling, all right, everybody wake up. Something's changed, so check again and see if you can get back to work.
And this is basically the anatomy of a correct solution. It's got four essential parts. First, you need a synchronized block. That's your lock, making sure only one thread can mess with a buffer at a time. Then, inside that block, you need a while loop. And I mean a while loop, not an if. That's super important. We'll get to why later. This loop keeps checking the buffer's state. If things aren't right, you call wait. And then finally, once you've added or removed an item, you call notifyAll to let any sleeping threads know it's time to wake up.
Okay, so this is where the interview starts to get really tricky. You've written the code. It looks great. But now the interviewer throws you a curveball. They describe a buggy system, and they're not just testing your book smarts anymore. They're testing your debugging instincts. Can you spot those super subtle errors that can bring an entire system crashing down?
And they'll give you a scenario just like this. Now listen closely, because the key phrases are hangs sometimes and only under high load. That's a massive clue, right? It's telling you this isn't some simple, obvious bug. This is a concurrency issue. It's a really subtle flaw in how the threads are being managed.
Okay, so remember when I said while, not if? This is trap number one. Here's the deal. Sometimes a thread can just wake up for no good reason. It's a weird thing called a spurious wake-up. Now, if you used an if statement, that thread wakes up, thinks, okay, I'm good to go, and just barrels ahead, even when it shouldn't. But a while loop? It's smarter. It forces the thread to wake up and immediately recheck the condition. That's what makes your code robust against these bizarre little edge cases. And trap number two, this is almost certainly the culprit behind that system hang. It's using notify instead of notifyAll. See, notify wakes up just one single arbitrary thread. So let's play this out. Imagine the buffer is totally full, and you've got a bunch of producers waiting. A consumer finally comes along, takes an item, and calls notify. But what if? What if the thread it wakes up is another producer? Well, that producer looks at the buffer, sees it's still full, and just goes right back to sleep. Meanwhile, the poor consumer who actually could do something is still sleeping. And just like that, your system is deadlocked. notifyAll avoids this whole mess by waking up everybody. It guarantees the right thread will eventually get a chance to run.
Okay, the interviewer is impressed. You've totally nailed the bugs. But they're not done. Now comes the real-world stress test. The system is deadlocked in production. Right now. How do you figure out what's wrong? They want to see if you can think like a real engineer who's on call at 3 a.m.
And this is where you really show your senior level thinking. You don't panic, you don't guess, you have a process. Step 1, you capture a thread dump. It's basically a snapshot of what every single thread is doing at that exact moment in time. Step 2, you comb through that dump, looking for any threads that are stuck in the waiting state. And Step 3, you diagnose the problem. You figure out why they're waiting, and you confirm that absolutely no other thread is in a position to ever notify them. That's your proof.
Man, you've navigated every single trap they've thrown at you. Now comes the final question. This is the one that separates someone who just memorized the solution from a truly pragmatic engineer. The interviewer looks at you and asks, "So, knowing everything we just discussed, would you actually build it this way in a real project today?"
And your answer should be a quick, confident no. Absolutely not. Look, you've just proven that you can do it the hard way, right? That you understand the low-level mechanics. That was the whole point of the exercise. But now, you're about to show them you know a much better, much safer way.
This is when you bring up the modern, professional move. You use Java's built-in BlockingQueue. It's a class that was literally designed to solve this exact problem. It handles all that tricky locking, waiting, and notifying stuff for you under the hood. The result? It's thread-safe by design. Your code becomes incredibly clean and simple, and most importantly, it pretty much eliminates the risk of those nasty, subtle deadlocks we've been talking about. It is, without a doubt, the right tool for the job.
So, you've aced the technical part. You've aced the debugging. You've aced the modern design. But there's one last thing, the grand finale. The why question that proves you don't just know the answers, you have a deep, fundamental understanding of the whole topic.
And believe me, this is their favorite final question for a reason. It's basically an open invitation for you to summarize everything, all the tricky parts, all the traps we just walked through. This is your moment to deliver that knockout punch and leave an incredible, lasting impression.
And that right there, that is the perfect, concise answer. It shows that you get it. The problem isn't just about writing a few lines of code, it's about managing immense complexity. You're pointing out that one tiny mistake, using an if instead of a while, or notify instead of notifyAll, can lead to these catastrophic bugs that are just a nightmare to track down. And your answer perfectly explains why tools like BlockingQueue even exist in the first place. They were built to handle that complexity for us. And with an answer like that, you haven't just passed the interview, you've absolutely